Okay, alright, so in the last class we have studied about how to perform ionic bonds and how to perform covalent bonds. Today we are going to study the properties of ionic and covalent compounds. Okay, so during ionic bond what happens is that if you do remember that during ionic bond metals, for example, this is a metal atom, the outermost shell, this is the nucleus, this is an electron, okay, and then this is a non-metal, sorry, okay, then this is a non-metal. What's going on? Just wait. Okay, so here we go. So look, for example, this is a non-metal and this is the electron in the outermost shell of, oh sorry, this is the metal and this is the electron in the outermost shell of the metal. Okay, this is a non-metal and these are the electrons in the outermost shell of the non-metal. So what happens is that metal gives its outermost electron, all right, metal gives its outermost electron to the non-metal and makes the region paired. Okay, so this region becomes paired after metal gives its outermost electron to the non-metal. Then this metal, since it is losing electron, it becomes positive charge, and the non-metal, since it gains an electron, so it becomes negative charge. Okay, so that's the case. All right. Okay, so now the thing is that we are looking at the properties of ionic and covalent molecules. Before going into that, let's see that how ionic and covalent molecules are stabilized. Okay, look, first let's look at an ionic compound. For example, I am looking at uh, AmGCl. No, not Cl. I am looking at AmGF2, magnesium fluoride. So here is a metal and this fluorine is a non-metal, isn't it? So magnesium is a metal and fluorine is a non-metal. So there must be ionic bond between them. Metal and non-metal for O-level standard, you in short get to know that metals and non-metals always form ionic bond. Now a bonding, metal is always positive charge in the bonding and non-metal is always negative charge in the bonding. Okay, so there is an attraction between the positive charge on the metal and the negative charge on the non-metal. So it's a positive negative attraction, and this attractive force depends on the charge and the size of the ion, but I think size of the ion may not be included in your O-level standard. But let's look at the charge. So magnesium has got a 2 plus charge, fluorine has got a minus charge. So whatever it is, it's a plus minus attraction. So positive negative attractions, we always whenever there is a positive and negative attraction, we call it electrostatic force of attraction, and if there is a repulsion between charge, we call it electrostatic force of repulsion. So, since there is a positive negative attraction, which we are calling it as electrostatic force of attraction, and you must remember that these electrostatic force of attraction, they are always very much strong. I mean, this electrostatic force of attraction, they are always very much strong, whatever it is. So, these attractive forces are very much difficult to break. The property of a substance depends on the this kind of attractive force between its particles. Okay. All right. So, in ionic compounds, the particles the particles are the ions, like this is the negative ion, and this is the positive ion, and this is the negative ion. So, in ionic compounds the particles are the ions. So, the properties of an ionic compound will depend on the intermolecular force between the ions. All right. Sorry. So, what you now need to know is that the properties of ionic compounds, the properties of ionic compounds the properties of ionic compounds basically depend on the strength of electrostatic force of attraction between the opposite charge ions. Okay. Okay, so let's get to look that what's going on between the opposite charge ions. Okay, so look, first of all, number one, ionic compounds, they have got very high melting points. So, why does ionic compounds have got very high melting points? Melting point means, melting point is the temperature at which a solid turns into a liquid. So, you know that in case of ionic compounds, the opposite charge ions, they attract each other by a strong force known as the electrostatic force of attraction, and this attractive force is so strong that it needs a lot of heat energy to get rid of. So, when you want to break the strong electrostatic force of attraction between the ions, you must apply a lot of heat energy, which means that they have so since you have to apply a lot of heat energy, that means that all the ionic compounds has got very high melting point. Now, if the amount of charge increases, like it turns out to be A 2 plus and B 2 minus or even B minus, if both the charge or if any one of the charge increases, then the strength of electrostatic attraction will also increase, which means that the melting point would increase, because since the strength of electrostatic force has increased, so you need to apply a greater amount of heat to break the attractive force. Okay. Okay. Done. Okay. So, next let's go to the second property, number 2. They do not conduct electricity when solid. So, ionic compounds do not conduct electricity when they are solid. let's see how and why. Okay, look, so for example, now what do you mean by electricity conduction? What is the meaning of electricity conduction? First of all, electricity means presence of charge and conduction means movement. So, electricity conduction or electric current conduction means movement of charged particles. In case of metals, the charged particles are electrons, and in case of ionic compounds, the charged particles are the ions, the positive and the negative ions. So, if electricity has to be conducted, that means there must be electric current present, then the charged particles must move. Okay. So, I am repeating it again. So, in case of metals, the charged particles are electrons, and in case of ionic solids, the charged particles are ions, the positive and the negative ions. Okay. So, do not be confused. When you are talking about ionic compounds and their properties, do not ever bring electrons in case of ionic solids. Okay, be careful. Okay, so for example, I am taking one ionic solid A plus and B minus. Okay, so there is strong electrostatic force of attraction between the positive and the negative ions, for which this ion will not allow this ion to move. That means, the positive ion will hold the negative ion strongly, so that the negative ion cannot move, and similarly in opposite way, the negative ion will hold the positive ion, so that the positive ion cannot move, because of the strong electrostatic force of attraction present between them. That means, in the solid state, the ions cannot move because of the strong electrostatic force of attraction between them. So, in solid state, the ions are not able to move, that means, charged particles are not able to move. So, in solid state, the ionic compounds would not conduct electricity. Okay. Now, then what happens in liquid state or molten state? So, molten means already melted by direct heating, and aqueous state, there is another state called the aqueous state. Aqueous state means it is dissolved in water. For example, when you are dissolving sodium chloride from solid state then to water, we call it NaCl aqueous. Aqueous means dissolved in water. All right. Okay. So, when it is molten, look, molten means you have applied heat and the solid has turned into liquid. Okay. When you are applying heat, it solid has turned into liquid. Like when you are heating ice means, ice means solid water. So, when you are heating ice turns into water, isn't it? You can call water as molten ice. Okay. So, for example, Na and Cl, there is strong electrostatic force of attraction between them, but so that is why the ions are not able to move, they are held in place. Okay. But when you are applying heat, this attractive force, the electrostatic force of attraction weakens, and the ions begin to move or wander about quite freely, isn't it? Because the force of attraction has weakened, right? The force of attraction has weakened. So, so you can easily the force of attraction has weakened. Where did the diagram go? Okay, the force of attraction has weakened. So these ions can now move quite freely. All right. Okay, so that's the point. So that means the ions are now able to move. Since the ions are able to move, so they must so they can now conduct the electricity, because electricity conduction means movement of charged particles. Now let's see what happens in aqueous state. All right. Okay. In aqueous state, what happens is that, look, water has okay, no, let's not go into details of property of water. In aqueous state, what happens is that, for example, this is a sodium ion. What kind of sodium ion is this? Sorry for that, my drawing is very bad. And the chloride ion. Okay, so when the sodium chloride is dissolved in water, what happens is that water molecules gathers around this sodium chloride part, isn't it? Many water molecules gather around the sodium chloride part, and interestingly, you will get to know in your higher studies that water has got two terminals, the positive hydrogen terminal and the negative oxygen terminal. Okay. So, water has got two terminals, the positive hydrogen terminal and the negative oxygen terminal. Okay. So, the positive, let me go deep inside. So, the negative oxygen terminal of water, we call it slightly negative. So, negative oxygen terminal of water gathers around sodium and starts to pull it due to attraction. Okay, this is also electrostatic, this attraction is also electrostatic force of attraction. Okay, and the positive hydrogen terminal, we are calling it slightly positive. This symbol actually means slightly. Okay, so the positive hydrogen terminal gather around the chloride ions and starts to pull the chloride ions. Okay. Suppose, imagine that this is the electrostatic force of attraction between the ions, but look, the ions, the sodium ion and the chloride ion, they are pulled apart by the water molecules, isn't it? Oxygen is pulling the sodium ionic part, and hydrogen is pulling the chloride ionic part. So that means due to attraction from both sides, it's like stretching, it's like two people, it's like two-person pulling, it's like two-person pulling a rope from two sides, isn't it? Okay. So now if two-person pulls the rope from two sides, then the rope would tear apart, isn't it? The same thing would happen in this case. The electrostatic force of attraction between them will get broken, and sodium and chlorine will move apart away from each other, and they will now become free, isn't it? So, when they are dissolved in water, the electrostatic force of attraction between the ions also breaks, and the ions also starts to move. So, this since the ions are now free to move and the ions are moving in the solution, so the aqueous solution will also conduct electricity. Okay. But here is one thing, this is very important to know, that when you are dissolving an ionic compound, when you are dissolving an ionic compound in water, the ions separate, right, as what we have understood. The ions separate, but at the same time water molecule also dissociates into ions, and you have to memorize it. I will go into details later, but right now you have to memorize it, that when any ionic compound is dissolved in water, the ions separate. Okay, that's all right. The ions separate and they starts to move freely, but at the same time water molecule also dissociates into hydrogen ion and hydroxide ion. At the same time water molecule also dissociates into ions. Let me give an example. For example, potassium nitrate is dissolved in water. So, what happens is that potassium nitrate will get broken down into potassium plus and nitrate minus, but since they are dissolved in water, then at the same time water molecule will also get broken down into hydrogen ion and hydroxide ion. Okay. So, in aqueous solution the ions are forcefully moved apart or separated apart by the interference of water molecules, and water molecules also dissociates into ions. So, aqueous solution has got a lot of ions, and aqueous solution has got a lot of ions. So, lot of moving ions. So, aqueous solution will also conduct electricity. So, our conclusion is ionic compounds, if they are solid, the ions are not able to move because of the presence of a strong electrostatic force of attraction. The ions are not able to move, so they will not conduct electricity. But in aqueous state or the solid but in aqueous state, that means when they are dissolved in water, or in molten state, that means when they are melted due to heat, the ions are able to move quite freely. So, they will conduct electricity. Okay. So, that is very important. Okay. Okay, so that's all about the properties of ionic compounds. Now we have to know the name of the structure of ionic compounds. You know that ionic compounds, there is strong electrostatic force of attraction between the ions, for which the ionic compounds are solids. But the ionic solids, they are also called, since it has a solid structure, so we would call it a lattice. And in the lattice, that means the solid structure, the particles present are the ions. So, we will call it ionic lattice. Okay. Now, what happens is that all the ionic lattice are giant structures. That means in a single lattice or in a single part of lattice, huge, almost huge, infinite number of ions are joined together by the strong electrostatic force of attraction. Infinite number of ions in a part of lattice or in any part of the lattice. So, we call it a giant ionic lattice structure, and it is drawn as hexagonal structure like this. I am taking red color to represent positive ions. Oh, the lattice is not yet finished drawing. So, this one, this one, this one, this one. So 1, 2, 3, 4. Okay, and I am representing green as negative ions. Okay, so this is called a single unit of lattice, but make sure that this is just a part, isn't it? So this part can have infinite number of extensions, like you can draw another part here, right? Isn't it like this? We can draw another part here like this, and the diagram will extend here. This is positive, so this no, this is negative, sorry, this is negative, so this would be negative and this would be positive. Okay, so this figure will carry on extending and extending and extending, which means there might be infinite number of ions in a single lattice. So that's why we call it a giant lattice, giant ionic lattice structure. Okay. Okay, so I have some few questions for you. You have to answer it and tell me in the comment section. First of all, what is the name of the force of attraction present between the ions, present in the ionic compounds? Okay, then number 2, is the attractive force very strong or weak? Is it very strong or is it very weak? Number 3, okay, if sodium chloride has the charge of Na plus and Cl minus, and magnesium chloride has got a charge of Mg 2 plus and Cl minus, which has got a stronger electrostatic force of attraction? Is it sodium chloride or magnesium chloride, and why? Okay, so this is number 3. So talking about number 4, which one has a higher melting point? Is it magnesium chloride or magnesium oxide? Which one has got a stronger electrostatic force of attraction? Is it Mg2 plus or Mg2 plus Cl minus or Mg2 plus and O minus? Okay, and fifth, okay, the fifth is calcium sulfate. No, not calcium sulfate. Calcium fluoride is an ionic compound. It does not conduct electricity when it is solid. Explain why. But it conducts electricity when it is molten or it is dissolved in water. Explain why. Okay, this is question number 5. And then question number 6, explain why magnesium oxide has got a very high melting point. Okay, and question number 7, draw a structure of sodium bromide and explain it in details. Okay, so these are the questions that, oh, there is one more thing left, I just forgot. Okay, let me go for explanation. That all ionic compounds are brittle in nature. Okay, ionic compounds are brittle. What do you mean by brittle? Brittle means it breaks off very easily, like when you are trying to bend it or fold it, it breaks off. Like, look, for example, you are applying small force on this rod, and what happens is that the rod breaks off. Okay, the rod breaks off from here. So this is what we call brittle. Like glass, glass is a brittle substance, and you must remember that all ionic compounds are brittle in nature. Let me explain why. Why all ionic compounds are brittle? Let's see. Consider that you have a series of positive and negative ions. 1, 2, 3, 1, 2, 3, 4. Okay. No, no, no. Okay. So these are the positive ions, and these are the negative ions. No, it's a wrong drawing. I'm sorry for that. So ion, 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 ion. So this is positive, negative, positive, negative, negative, positive, negative, positive. Okay. Okay. So there is strong electrostatic force of attraction. There is very strong electrostatic force of attraction between all these ions. Okay, between all these ions. Now imagine that you are trying to deform. Imagine that you are trying to deform this solid structure. Okay, so what you are doing is that you are applying force in the top layer of ions. Okay, so now what happens? So when you are applying force on the top layer of the ions, just think for instance that this layer will slightly move in forward direction because of the force you are giving. Just think. So the bottom layer, first I am drawing. So the bottom layer remains as it is, but the top layer has slightly shifted in forward direction, isn't it? And then what happens is that this is very important, that look, the same charge ions is now beside each other, isn't it? The same charge ions is beside each other, for which there will now be a very strong repulsive force between the ions, and this will push the ions apart. That means the solid will break here, isn't it? Because this layer of ions are being separated and this layer of ions are being separated. That means the solid would break here. That means if you deform an ionic compound by a small amount, then for sure the ionic compound will break apart. For example, I can tell you, take a small crystal of salt, try to give a push or try to slide it, and it will be divided into grains or granules between your fingers. Sorry for the interruption. Okay, so all ionic compounds are brittle. So my seventh question is, explain why ionic compounds are brittle. Okay, so again, what's the meaning of brittle? Brittle means if you deform or try to change the shape of a solid, then the solid, instead of changing the shape, it will break apart, isn't it? Polythene, rubber, they are not brittle because they will change their shape quite easily. Graphite, then any lubricants, they are not brittle, isn't it? They are because they change their shape. Elastic rubber, it's not brittle. because when you apply force on elastic rubber it will change its shape, but glass is brittle, many plastics are brittle. Okay. Okay, so that's all for the class, chemistry class today. In the next class we will discuss about the properties of covalent molecules and the properties of metallic bonded particles on Wednesday the same time at 5. So stay tuned, answer the questions and inform the problems in the comment section, and within today by tomorrow you will get the lecture sheet of this class in the comment section. Okay, or you give me your email IDs, I will send you the lecture sheets. Please give your email IDs in the comment section. Okay, that's all for today. Thank you, and please inform your problem in the comment section. I will try to solve it again through video discussions. You can also add me in WhatsApp to the problems. My WhatsApp number is 01749339690. Okay, so all the best Science Academy, all the best Skillshare Education. Okay, thank you.